Good evening, children. How are you? I hope you all are fine and understanding well. My first part of circle completed. Today I am going to start second part of circle. In second part I have given all theorems. In first part definition and concept was, and it is my second part theorems of circle. Theorems of circle. First theorem is a straight line drawn from the center. A straight line drawn from the center of a circle to bisect a chord. A straight line drawn from the center of a circle to bisect a chord which is not a diameter. That means is not a diameter, is at right angles to the chord. This chord is not a diameter, is right angle at right angles to the chord. Once again, a line drawn from the center of the circle, to bisect a chord which is not a diameter. That means this line drawn in a circle, the line drawn from the center to a chord, a line drawn from the center to a chord. This chord is not a diameter. Drawn bisects the chord, is at 90 degree, at right angle, is at right angles to the chord. In this circle I have drawn this circle and AB is chord. OC is a line drawn from the center, bisects the chord. That means given a circle with center O, a complete circle is given with center O. Second number given OC bisects AB. That means AC is equal CB, and construction join AO and OB is construction. Now proof, what we have to prove? We have to prove this angle OCA is equal OCB is equal 90 degree. That much only have to prove. To prove OC perpendicular to AB. And now proof is, we will take triangle OAC, in triangle OAC and OBC and triangle OBC. All of you understand, in a circle a fixed distance from circumference to the center is a radius. That's why, and all radius are same. All radii are same. That's why in triangle OAC and OBC both radius are equal. OA is equal OB. OA is equal OB. Both are radii. Both are radius. And second thing, OC is equal OC. OC is equal OC, it is common. Is it common? OC is equal OC, common. OA is equal OB, and already given line OC, line segment OC bisects the chord. It means AC is equal CB. That also given. So AC is equal BC. Both are given equal. The bisect. So it is given. Now from which property? From S postulate. From S postulate, both triangles are congruent. Triangle OAC is congruent to triangle OBC. Both are congruent. And congruent, it means if both are congruent by SSS, so both are congruent and angle ACB is straight. The line as ACB is straight, so angle OCA is equal angle OCB. CB is equal 90 degree by CPCTC. By CPCT. By CPCT, both angles are same, and as this line is straight, so it is 90-90. Both are 90-90, and that's why both angle equal and it is 90 degree, implies we can write OC perpendicular perpendicular to AB. OC perpendicular to AB. OC perpendicular to AB. That was to prove OC perpendicular to AB. Now first part of this theorem is proved, and second I am going to prove converse of the theorem. Converse of the theorem. Converse of the theorem. The perpendicular to a chord from the center of the circle bisects the chord. In direct theorem, it was the line drawn from the center which is given bisects the chord is perpendicular. And second thing, converse of the theorem is given, the perpendicular, already given perpendicular to a chord from the center of the circle bisects the chord. That means in this time you have to prove this perpendicular bisects the chord. Okay, so I am going to prove it. In converse of theorem, we have to prove converse of the theorem. To prove AC is equal BC. And what is given? A circle is given with center O, as I have written in direct theorem. Say circle with center O, and was given the it is circle and is given OCB perpendicular to AB. That means OC is perpendicular to AB. It is given, and we have to prove AC is equal BC. I think it will be better to write what is given. That also is given. A circle with center O, and second thing is given is 90 degree. Angle OCB is equal angle OCA is equal 90 degree. It is given. This angle is 90 degree. It is given. Now to prove, what have to prove? We have to prove AC is equal BC. AC is equal BC. Now prove. Again, in triangle OAC, and triangle OBC, in triangle OAC and OBC, as AC is equal BC, is given, both are equal and radius are same. Radius is same. So OA is equal OB. OA is equal OB radius. Both are equal. And third thing, angle OCB is equal angle OCA is equal 90 degree. It is given. So from which postulate? Remember, recall all of you, two sides are given. One side is given, one hypotenuse is given, and one angle is 90 degree. That means it is by RHS postulate. By RHS postulate. By RHS postulate. Triangle OAC is congruent to triangle OBC. Both triangles are congruent, and if both triangles are congruent, then obviously these two sides are equal. That was to prove AC is equal implies AC is equal BC by CPCTC. This theorem is proved. Converse of the theorem, the perpendicular to a chord bisects it. That was converse of the theorem, and it is given it is 90 degree. Both are radius, and OC is common. So by RHS postulate, both triangles are congruent, and that's why this AC is equal BC. It was to prove. It is converse, not direct theorem and converse. It is direct theorem and it is converse. Both are proved. Next, I am going to prove second theorem. This first part, second part, they are converse. Now third number. Equal chords of a circle are equidistant from the center. In a circle, two or more than two chords are given, which all are equal chords, then they all are at equidistant from the center. That means suppose one circle is given and there are many chords, all are equal. All chords are equal to each other, then all chords have equal distance. Distance means perpendicular distance. All have perpendicular distance at equidistant. All distances are same. That we have to prove. Equal chords of a circle are equidistant. Equal chords are given. There are many chords are given. All are equal. They all are equidistant from the center. All are equidistant from the center. That means this perpendicular distance, all distances are same. That we have to prove. Like that I have drawn one circle. One circle is given. There one given one circle, a circle with center O. It is given, and second number is given. Second number given equal chords. AB is equal CD. AB is equal CD. Now to prove, what we have to prove? To prove OP, both are at equidistant. That means these perpendicular distances are same. We have to prove OP is equal OQ. OP is equal OQ. Both are equal. That we have to prove. Now construction. Your construction is join OB and OD. Join OB and OD. Then proof. The proof. Their construction, join OB is equal OD. OB is equal OD. And given AB is equal CD. So now proof is, we will start from triangle. Otherwise we can start from AB is equal CD. They are given AB is equal CD. It is given. Dividing both sides by 2. Both distances divided by 2 implies AB by 2 is equal CD by 2 divided by 2. Then AB by 2, AB by 2. From first number theorem, AB by 2 means PB. Their first number given a straight line drawn from the center of a circle to bisect the chord which is perpendicular. Already theorem we have proved. That's why this perpendicular is bisector of AB, and AB by 2 means PB is equal CD by 2 means QD. It is first number. It is first number. And second, OB is equal OD. OB is equal OD. Radius. A radius. And angle OPB is equal OQD. Angle OPB is equal angle OQD. Is equal 90 degree. Already it was given. It is given 90 degree. Now from which postulate? By which postulate? Both are congruent. Right angled hypotenuse and any one side. It means by RHS postulate. RHS postulate. By RHS postulate. Both triangles are congruent. Triangle by RHS postulate. Both triangle. I am writing from here. Triangle OPB congruent to triangle OQD. Both are congruent, and if both are congruent, so OP is equal OQ implies OP is equal OQ by CPCTC. OP is equal OQ. That means your theorem proved equal chords of a circle are equidistant from the center. That is proved. Next, I am going to prove converse of the theorem. Chords of a circle equidistant from the center. Chords of the circle. Converse of this theorem. Chords of the circle equidistant from the center of the circle are equal. That means in converse, what is given? Fourth number is given. The chords of a circle, that means two chords are given. They are not given equal chords. In converse, chords of the circle, in any circle, all chords, many chords are given, suppose. Like this, many chords are given. And if they are at equidistant, all distances are same. All distances are same. It means chords are also equal. It means chords are equal. If all the distances, perpendicular distances are same from the given chords, that means all chords are equal. That is a converse of the theorem. It means what is given in converse? In converse, you are given chords of a circle equidistant. They are not given. Or equidistant, it means given OP is equal OQ. OP is equal OQ given. To prove, we have to prove AB is equal CD. We have to prove construction. What is construction? Join OB and OD. OB and OD. Now to prove AB is equal CD, so prove. It is to prove. And how we will prove it? AB is equal CD given, OP is equal OQ given, AB is equal CD. We have to prove in triangle OPB and triangle OQD. In both triangle, this triangle and this triangle, in both triangle, it is given equidistant. That means PO is equal OQ given, OP is equal OQ is given, and as from the first part converse theorem, the perpendicular to a chord from the center of the circle bisects the chord, and first part was a straight line drawn from the center of a circle to bisect a chord which is not a diameter is at right angles to the chord. This is equidistant. Both are equal and perpendicular also. Is it? Perpendicular also. So angle OPB is equal angle OQD is equal 90 degree for any distances. If both are equidistant, that means their distance equal and they are perpendicular also. So both angles are equal to 90 degree. Next, yes, this hypotenuse also equal. Radius. OB is equal OD as it is radius. Both are radius. These two are radius. It is equidistant. Both are equal and there is a 90 degree, 90 degree. Again by RHS theorem. Again by RHS, both triangles are congruent. By RHS, triangle OPB congruent to triangle OQD. Both are congruent and show by CP/CTC PB is equal implies PB. By CP/CTC PB is equal QD. PB is equal QD. And according to the theorem, this one, if a perpendicular and equidistances, that means it bisects the chord. So multiplying both by 2, PB is equal to QD implies it is AB by CD. Your theorem proved. Understood? Converse of third number also proved. Chords of a circle equidistant from the center of the circle are equal. Both chords are equal. This time given it is Equidistant, that means these both distances are same and perpendicular also. These two are given, and if these two are given, then it is a radius. That's why both are equal. So by RHS both triangles are congruent, and if both are congruent, so they are by CPCT, see, PB is equal QD. You can write there CPCT. Now your theorem complete. All theorems of circle, that means for first exercise